Worksheet 5, Part 2, Question 12. Silicon is the structural element in most photovoltaic cells. There's 4 things you could do to conserve energy. 1 is you could have energy efficient appliances. 2, you could switch to LED light bulbs. 3, walk, bike, or carpool whenever possible. 4, double pane southward facing windows would allow you to keep more of that energy within your house. Okay, so remember when we asked about conserving things, that we're answering the specific question. Pay attention if it's asking you to conserve water, to conserve energy, to conserve electricity, conserve fuel. Make sure you're answering the appropriate thing. State where Chernobyl is located and explain what happened there. Chernobyl is located in Ukraine, which was the site of a serious accident on April 26, 1986. It's a nuclear power plant. There was a test of the plant which took place without emergency cooling systems or control rods, and the reaction ran away and led to an explosion. 31 people died on the scene and many, many more after due to radiation. Let's review some of our mining. It'll be hard to fit all of this information into the chart, so you sort of have to just put a couple of the keywords, but let's sort of go through our different types of mining. Open pit mining, it's just what it sounds like. It's digging a big pit. Removing minerals such as gravel, sand, and metal ore by digging out of the Earth's surface and leaving an open pit behind. And environmental consequences include habitat destruction, erosion, runoff, surface water, and acid mine drainage. Subsurface mining. This is when you go deep down into the ground. This is your coal shaft that you're thinking of. So extraction of a metal ore or fuel such as coal from deep underground deposits. We typically don't see them from above, but dangers include cave-ins, explosions, fires, and black lung from breathing that in. Strip mining. It's a form of subsurface mining in which bulldozers, power shovels, or stripping wheels move large chunks of the Earth's surface in strips. Literally, we're mining big strips as we go across. Environmental consequences, it leaves a series of spoiled banks. It promotes acid mine drainage. Mountaintop removal is also exactly what it sounds like. Type of surface mining that uses explosions, massive power shovels, and large machines called drag lines to remove the top of a mountain and expose seams of coal underneath. Consequences include waste rock and dirt destroys forests, buries toxic mining minerals like arsenic and mercury can overflow from dam structures and disrupt groundwater. And then drilling, which can be both on land and in water. Drilling, both the harvest of natural gas and oil require drilling deep into the subterranean rocks and using the process of hydraulic fracturing. It can lead to ground instability or contamination of water. Strengthen this weak statement. Mining causes pollution that may disrupt the environment. Very true statement. Nothing wrong with that. Surface mining disrupts many habitats in the removal of the overburden to get to the ore. Remember, the overburden is what we're removing. It's the pieces of cookie that you had to remove to get to the chips down below. Subsurface mining may have acid mine drainage, which will lead to water pollution. More specific about the pollution, more specific about the damage to the environment. Match each of the following elements with its ore, so what it comes from. So galena is where lead comes from, that's D. Quartz is where we get silicon, which is E. Bauxite, which is where we get aluminum, which is A. Hematite gives us iron, which is B. And pitchblende gives us uranium, which is C. Explain what happened at 3 Mile Island and why it was important. Its location was in Pennsylvania. It was in 1979, the only nuclear event in the United States. The reactor partially melted down, but only minimum radiation escaped the containment unit. It happened because people on site overrode the in-house protections, and if they had just let the plant operate with its own safety features, it wouldn't have happened. Explain how thermal pollution is produced by power plants. So in most power plants, heat is produced when coal, oil, or gas are burned to release huge amounts of energy. And then let's review this. Energy heats water, which generates steam, which turns a turbine, which produces electricity. We say that a lot. The steam must be cold and condensed back to water. So cooling water is added to hot steam, and then it's not cold like the cold water in the lakes, but it's cooler. It's not steam anymore, but it's warm water, and it's added back into nearby lakes, streams, and rivers, which would definitely be thermal pollution. Explain what happened at Fukushima Daiichi and why it's significant. Occurred in March 2011 in Japan. An initial failure occurred when the plant was hit by a tsunami triggered by a magnitude 9.0 earthquake. Meltdowns occurred in 3 out of the 6 reactors. No fatalities or short-term radiation exposure were reported. Perform the following calculation. Show all of your work. A radioactive cloud may contain iodine-131, which has a half-life of 8 days. If the waste must decay to a concentration of less than 0.1% to be considered safe, it will take approximately, and it says 80 days. So let's show our work. We're starting with 100%. We're going to divide it in half. A half-life would get us to 50. Half of that is 25. Half of that is 12.5. Half of that is 6.25. And half of that is 3.13. Half of that is 1.56. Half of that is 0.78. Half of that is 0.39. Half of that is 0.195. Half of that is 0.097. We've gone through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 half-lives. 10 half-lives, each 8 days long, gives us a total of 80 days. Perform the following calculation. Show all of your work in a logical progression. A family has a 75-meter squared solar array in front of their house, which has an efficiency of 10%. If the average installation on their array is 6 kilowatt hours per meter squared per day, and their average cost of electricity is 20 cents per kilowatt hour, the family has the capacity to produce, it's going to say $9 and $3,285 annually from the sun. They have 75 meters squared. They produce 6 kilowatt hours per meter, times that 10% efficiency, and the average cost is 20 cents per 1 kilowatt hour, so they're going to produce $9. Multiply that by 365. That'll tell us how much that we produce per year.